Alright, in this section we're going to look at estimating derivatives at a point. And so there's several ways that we can estimate a derivative at a point. And the first way that we're going to do is from a table. And so this asks us to use the table to estimate f prime of 4. And so remember f, just for notation purposes, f prime of 4 is the slope of the tangent line to f of x at x equals 4. And of course that slope of the tangent line, that is our derivative. So just making sure we're very clear on all of that. So you can see here you do not have 4 in your table here. Whenever we're estimating the derivative from a table, we want to find the slope of the 2 points closest to 4. So 4 would fall in between 2 and 5 here. And so what we want to do is we want to take the 2 points closest there to 11 and 5, 7, and we're just going to do that slope formula. So we know that that slope formula is y2 minus y1 over x2 minus x1. And so make sure you put your y's on top. I can't tell you how many calculus students miss points on test for putting the x's on top, so be careful with that. You're going to do 7 minus 11 over 5 minus 2, and so that's going to give you negative 4 over 3. So we have a slope of negative 4/3. This would be your best estimate here of the slope. We could write our answer like this: f prime of 4 is approximately negative 4/3. This would probably actually be the best thing for us to circle as our answer. So we're labeling this as f prime of 4, and we're, instead of using an equal sign, because certainly we don't know that the slope equals negative 4/3, we're going to use the approximately sign, which is a squiggly equal sign here. That means, oh, it's pretty close to negative 4/3. Alright, let's move on. We also are going to estimate slopes from graphs. So use the graph of g of x to the left to estimate f prime of 0, f prime of 6, and f prime of 4. So if we look at our graph here, we are estimating the slope of the tangent line. And so x equals 0 right here. So we're looking at this point on the graph when we're looking at f prime of 0. And so right now we really are just estimating. So we are guessing what that tangent line looks like. So if I draw that in here, let me see if I can get something that I think looks reasonable. It's probably pretty close right there. So I'm just guessing at what I've got here. And so if I look at the graph here, the slope of this line, now I am going up by 2 on both the x and the y axis. So I'm going down, looks like 1, but you're going down 2 and over 4. Down 2 over 4, maybe not quite, but pretty close to down 2 over 4, which is also down 1 over 2 if you reduce it. So actually I should not use the equal sign. I should use an approximately negative 1/2. So that's a decent estimate. Now it might not actually be exactly negative 1/2, but it's a decent estimate. It's important here that your slope is negative, and it's fairly close to what that actual slope is. Now, if we look at f prime of 6, if we look on our graph here, I'm going to use purple for this one. 6 is right here. This would be 6. So our point on our graph is right here. And if we draw ourselves a tangent line in here, some purple. It's not very good. Let's adjust here. That's probably pretty close right there. So I might go down a little bit. Okay, so if we look at our graph here, if we're just estimating the slopes, that there's a point that's on grid lines. This one's pretty close to being on grid lines. We're not exact, but pretty close. We're just going down 1, right 1, or down 2, right 2 here. So I would estimate that that slope is about -1 there for that one. We also need to find f prime of 4. Now, f prime of 4 is going to give us a little bit of trouble here, because 4 is right here, and we can see this graph appears to have a vertical asymptote at 4. So the graph is not defined, which means the derivative also cannot be defined. So for this one, we would say that this is undefined. Okay. Example 3 asks us true or false. For all x's in the domain of f prime of x, all x's in the domain of f prime of x is less than or equal to 0. And so if we think about what this means, for all x's in the domain of x, so that means everywhere this function is defined. And this function is defined everywhere except at that vertical asymptote. So this is telling us everywhere except at x equals 4, because we have a vertical asymptote there. It says f prime of x. Let's remember what that f prime of x means. That's the derivative or our slope of the tangent is less than or equal to 0. And if something is less than or equal to 0, it is negative or equal to 0. Right, so either 0 or negative. So if I look here, this graph is constantly decreasing all the way until I get to that vertical asymptote. So my tangent line would also be negative. Every line here would have a negative slope. The same thing is going to be true here. I'm decreasing the tangent line in all of these cases. Right here I'd have a really steep line. Here it's less steep. Over here I'd have a really not steep at all line, but it's still going to be decreasing a little bit. So for this case, it would be true that for all of the x's in the domain of f, f prime of x is less than or equal to 0. Alright, let's keep going. Your textbook is going to have some of these problems, and they're a little bit weird. We are going to look at what it means. So you'll have a graph like this, and it says fill in each blank with a greater than or less than sign. And so what we have here is we have a bunch of slope formulas and derivatives to compare. So whenever I see f prime of -1 minus f, I'm sorry, not f prime, f of -1 minus f of -3 over 2. Let's think about this for a second. If I have points -1, f of -1, and a point -3, f of -3, then if I were doing slope formula, I could do f of -1 minus f of -3 over -1 minus -3. And of course I have that double negative there, so I would get a 2 in the denominator. So that would give us this right here. So what this is finding is just the slope between where x is -1 and where x is -3. So on this graph, we have, we'll do this in blue. We're looking at the slope of this line. We've got -1 right here. We've got -3 we're looking at the slope of this line. Okay. We also have, I'm going to use red over here, f of -3 and 5. And so this is also a slope formula. If we do -3 minus 5, we'll get -8 right here. So this is the slope between -3, f of -3, and 5, f of 5. And so if I look at my points here, at -3, I've got this point right here. At f of 5, I'm up here. And so I'm not even going to try to figure out what numbers I have here. I'm just going to draw this in. And so the steeper a line is, the higher its slope is going to be. So for this particular problem here, I would have that this blue line, just this part, is steeper than this red line. So I would have a greater than sign. All right, I'll erase this so we can see. Let's now look at this. We're asked to find here f of -3 minus f of -1 all over -3 minus -1. This is the slope between -3 f of -3 and -1 f of -1. It's really no different than what we have up here. So it's that same blue line that we were looking at earlier. I could have just left that there. And then it's asking for f prime, is red for this, f prime of -3. So this is the slope of the tangent at x equals -3. So x equals -3 we're talking about right here. And if we're drawing in a tangent line, it's going to look something like that. And I don't know the values of these, but I can see that red line is a little bit steeper than my blue line. So when I fill this in, I would put a less than sign because that slope of that tangent line at x equals -3 is a little bit steeper. Now, if we look here, we have the same thing, that same blue line right here for part C. And then we're asked about the slope of the tangent line at x equals -1. So rather than looking at that red line that we have here, I'm going to erase that, and I'm going to add in f prime of -1 right here. So f of -1 is this dot, this red dot that I'm adding right here. We're looking at a tangent line to the graph. And here you can see that blue line is steeper than the red line. So since that blue line is steeper than the red line, it has a greater slope. So we would use a greater than sign for numbers for the letter C. All right, let's look at some. All right, so we have to label all of these things on our graph. So if I look at f of -2, whenever our x equals -2, our y equals 0. So this would equal 0. And so this point right here is going to be -2 f of -2. So f of -2, that is your y coordinate. And so if I were going to label this, let me make this a little larger so we can see it a little better. If I'm going to label this on my graph, on the y-axis right here, this is f of -2 right there. And so I'm going to label f of 0. F of 0 on my graph, you can see right here, if I plug in 0, I get 4. So it's going to be 4. And again, this is the point right here, 0, f of 0. So f of 0 is your y coordinate. So this is f of 0 on your y-axis. Now it asks us to label f of 0 minus f of 2. Now this is really easy to find because we just have to do 4 minus 0, which is 4. I think it's a little more difficult to think about how to label that. But think of this, when we subtract, we're finding the difference between f of 0 and f of negative 2. So the difference is this distance right here between f of 0 and f of 2. So this green line that I've put here, this is f of 0 minus f of negative 2. Okay. Now you can see that I've got f of 0 minus f of negative 2 over 0 minus negative 2. And hopefully by now you're recognizing this as slope formula. So if I plug those numbers in, I've got, I have, let's see, f of 0 is 4 minus f of negative 2, which was 0, over 0 plus 2, which is going to give us 4 over 2, which of course is 2. Now, I am not going to label that, mostly because we're going to really see this in the next problem. So now, if you look at what I've got here, I've got this big, long mess of things here, and I have y minus f of negative 2 times this slope formula times x plus 2. And actually, the way that I taught you guys point slope is a little different than you see here, but we can recognize this part right here as our slope. And we can recognize right here that this is our x1. It's minus x1 actually. And this is a little different than I taught you guys point slope. Some versions of point slope do this. Y minus y1 equals m times x minus x1. I did not teach you that version. I taught you this version. Y equals m times x minus x1 plus y1. And so you can see the only difference here is just this minus y1. I moved over to the other side and made it positive. But if we're looking at this point right here, we can see that, let's see, this part right here is my y1. And so this is the equation of a line that goes through the point negative 2 f of negative 2. And so, and it has the slope of the line from 0 to negative 2. So what we're going to label here is this line right here. So I held off labeling that slope because I knew we were going to draw this line right here. So we'll label that instead. I'm not going to write this whole thing, but this goes right here. Okay. One other thing that we're going to need to be able to do is we need to be able to sketch the derivative of a graph. So, zoom back out a little bit here. If we're looking at this graph right here and we're asked to sketch a graph of the derivative, we could almost think of making a table here. And so if I look at this graph maybe at negative 8 right here, I'm just picking a point, then I'm looking for the slope of this line, and I didn't make it the easiest to tell the slope of this line. This looks like right here, like it'd be maybe at 3, and then right here, maybe we hit at 1 possibly. See if that looks accurate. So in this case we would go down 4 to the right 2. So that would be negative 4 over 2, which is negative 2. I think that probably is pretty good. We'll see if that looks right. So down, go down 2. So there's 1, 2, and then over 2. Down 2 over 1. Yeah, that looks about right. So we have a slope of negative 2. And then at, yeah, maybe negative 4 here. we have the same slope because this is a straight line, so it would also be -2. And then maybe at 0, we have that same slope. It's -2. And all the way up to this point, right here at 2, remember this is counting by 2's on the x-axis here. At 2, we really don't know what the slope is, because at 2, we have one slope on one side and another slope on the other side. And we'll talk more about exactly what that's called whenever we have that. But we don't really know what happens there. However, now if we switch over here to larger numbers, so if I go over here to, let's say, 4, at this point, now I've got a positive slope. So my slope is +2. And at 6, my slope would be +2. At 7, it's 2. It's 2 everywhere here because I have a straight line. So if I go to graph this, then at -8, -2, I have a point. At -4, -2, I have a point. At 0, -2, I have a point. I'm not sure what happens at 2 right here, but all the way up to 2, I'm going to put an open circle right here. -2 is my slope. And then at 2, my slope jumps up here to +2. And then after that, all of my points are +2. So the graph of this derivative will look like this. This would be f prime of x for this particular function. So what I'm doing here is at each point, I'm trying to estimate what the slope is and then plot that point over here on my graph of my derivative. Let's try another one. Okay, so this becomes a little bit more difficult to do whenever you have a function that's curved like we have here, because when we have straight lines, we can find the slope of the graph. But here we do not have straight lines. So to help us a little bit, I have made a Desmos graph that we are going to look at. I'm going to split screen this so we can see both here. And so here is my graph, and I have added a tangent line here so this can help us. And so let's zoom out a little bit over here so that we can see this whole graph. And so if we think about making a table here, then there are certain values that we will know. X, f prime of x. First of all, I know that at -5 and +5, that's where my graph's going to end. So 1, 2, 3, 4, 5. I'm not going to get past here or here on my graph. So there's my, I'm just going to label those, so I'll look for that. And so as I look at my slope, one thing I notice is I've got negative slopes all the way up until I get right here. And right here is a really important spot. I'm going to have a slope of 0. So right there at 0, I'm going to put this right here, I know that I'm going to have a slope of 0 because this line right here is a horizontal line, or pretty close to it. It may not exactly be a 0 there. And so I know I'm going to have the point 0, 0 on my graph. And then I'm going to have, after that, positive slopes all the way until I get over here. So if we think about what's happening here, maybe here at -1. If I estimate that slope, it looks like maybe it's -1/4, something close to that. There. But whenever I get over here to -2, it's steeper. So now maybe it looks more close to -1/2. And then at -3, now it looks a little steeper. I'm pretty close to -1. These are just estimates. They're not exact. I'm just estimating. And as I keep on here at -4, it's even steeper, closer to -2. And if you look at what happens, as I get closer and closer and closer to -5, my line becomes more and more and more vertical. So let me actually make myself a little bit more room on my table here. If it'll let me. I don't know if it will. Well, it won't. But let's just continue this here. If I had -4, then maybe it'd be like -2. But at -4.5, maybe now it's like -5. And then -4.9, it's going to be -15. And you can see these numbers get bigger and bigger. So if we think of plotting those, we would have -1, -1/4. That'd be close to here. -2, -1/2. Again, these are just estimates. -3, -1. -4, maybe -2. And then what we're going to see here is we're going to have a vertical asymptote, because this graph is just going to get steeper and steeper and steeper until it gets to this point right here. This is a semicircle, so it would technically be vertical if we got right there to that point. If we look on the other side, we've got sort of the same thing happening, but we've got positive values. So at 1, our slope might be +1/4, and at 2, it might be +1/2, and at 3, it might be +1, or something close to that whenever we look at this. So if we graph those points, we've got 1, 1/4, 2, 1/2, 3, 1, and then we're going to see here that we're going to have a vertical asymptote there as well. And so our graph of our derivative, our f prime of x, would look something like this. And let's see if it'll graph it for me. I think it will. Desmos is so cool. I don't know if it will. Let's check it. F prime of x. Look at that. Desmos will just graph it if you type in f prime of x. Isn't that cool? So whenever you're doing your homework, I really, really want you to sort of graph these, just thinking about these, because you certainly won't be able to use Desmos on the AP exam. But you can check your work on the problems like this by typing in f of x equals whatever the function is, if it's one that has a function, and then looking at f prime of x. Now, some of them may only give you graphs, so it might not help you that much on those, but it is kind of cool how this works here. All right, I've got one more thing that I want us to do, and we're going to use Desmos for this one also. This is a calculator active problem, and it says, at which x value does f prime of x have the greatest value? If f of x equals 1/5 e to the x, and all of this stuff right here. So I'm going to go over here to Desmos, and I'm going to graph this function. So I've got 1/5 e to the x times x minus 5 times x plus 2 times x minus 1. And so that creates this crazy looking graph over here. And so I'm being asked about the tangent line at each one of these points. I'm going to pause right here and put in a tangent. Now, I have added in this tangent line right here. So you don't need to know how to do that. I just want you to be able to see this visually. And so for this, we are asked to find where the derivative has the greatest value. So where the slope has the highest value. And so at first, and we're looking at x values, at first we're looking at -5.013. Well, I'm just going to see if I can tell this from estimating. So that'll just be a tiny bit below -5. And so if I'm estimating the slope of the graph there, I know it's negative. So f prime of -5.013 is about, it's negative, and it's not very steep. Let's see. Down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe about -1/10. That's a really gentle negative slope. Probably that's going to be good enough for us to know. We're not going to be, if they ask you to guess like this, they're not going to ask you to no, they'll give you ones where there's some difference. So at negative 3.531, so at negative 3.531, that is somewhere around here, and you can see it's almost horizontal here. So I would say that this one, the derivative, is almost 0, maybe exactly 0, not sure. Then I've got 0.889. So 0.889, actually, I didn't mean that. Let me fix this problem. I meant for that to be negative 0.889, so let's throw that in there. So at negative 0.889, that's about here somewhere. It looks like I've got a slope a little bit steeper than 1. So f prime of negative 0.889 is about 1, maybe a little more, maybe a little less. And then our last one is at 1.98. So that would fall around, probably around here somewhere, there, and it's also close to 0. Okay, so you can see that they've purposefully given us values here where we can tell the difference. So our first one was negative. B and D are both 0, and then right here, C, I have a clearly positive slope. So C would have to be the answer here. So whenever you're given a question like this, you're not doing limit definition of a derivative with this terrible long equation. You are just looking at the graph to try to find the function here. Now, I've graphed on Desmos just because it shows up a lot better here. You will probably, if this shows up on a test, you'll have to graph that on your graphing calculator. Okay, and the assignment that's going to go with this is on page 131. It's 1 through 4, 37 through 40, and 55 and 56. So please complete that for me and submit the pictures of your work on Canvas.